Hey guys, today we're doing an A-level physics P5 video again, and the paper we will be doing this time is the latest one, May-June 2017 P51, and I'm hoping that I'll be doing a lot of P5 videos of the latest question papers, the ones I find the most intriguing or the most diverse in what sort of skills they are testing. And again, in this part I'll do the question 1, and if I have time I'll also give an overview on how to do question number 2. Well, let's move on with it. As I said, focus on the question statement is key. You miss something out, you will lose a lot of marks and a lot of self-esteem. So go over the question with a lot of focus and either write down in the margins some key points or underline them or something, whatever fits you. So a student is investigating the motion of a wooden block on an inclined plane as shown in figure 1.1. Immediately we know what the question is about. We have this tilted, that is inclined plane, and we have a wooden block situated on said plane, and what we are doing is we are investigating the motion of the wooden block. And then when you see how on earth, what kind of motion are we talking about and how are we investigating said motion, just look at the diagram. We have the wooden block attached to a spring, and we have a pulley, and then there is a falling body. So you get a general idea. You might actually attempt varying the mass and then observing the subsequent change in the speed or the acceleration of the wooden block as it moves up the inclined plane. And these sort of questions were actually tested in P1 MCQ part, in which they had two wooden blocks that actually formed one single unit, and that is why in order to solve it and to get the acceleration, you'd have to use the total mass in some parts of the answer, in which you'd have to basically add up the mass of the falling body and the wooden block, and part of it you'd have to just take this as a unit. I'll explain this if the need arises. And the wooden block is initially at rest, that is V0, no acceleration, and it is at rest at point P, and it's actually the center of mass of the wooden block that is at P, and you must really keep the starting and the ending positions in mind, especially when it comes to what the starting position are relative to the body we are talking about, in this scenario being the center of the body. And it is at rest at point P and has velocity v at point Q, and obviously there would be some acceleration observed, and so there would be an increase, and by the time it is at Q it would have velocity v that is of an unknown value. So you have learned about the equations of motion in AS, and there were a lot of them. There was this one, v square minus u square 2 into A into S, and this was literally my favorite, and this was the one that was usually used time and time again. And there was also the S is equal to 1 by 2 AT square being the time plus UT, and these were basically the two that you'd need time and time again. And in this scenario it is the first one that is likely what you'll be interested in. So the displacement would be the distance between P and Q, right? Let's just represent it by PQ, and the acceleration would basically be, what is acceleration to you? It is the change in the speed per unit time. And in order to get the acceleration, you must realize that while this is a falling body and you'd expect to have an acceleration of 9.81, you won't have that. Why? Because this isn't the whole of the system. The acceleration is experienced by the falling body and the wooden block, and both the masses are involved. Easy peasy, and there might actually be theta which will come into play. So just get an idea of what the question is saying. So it is suggested that the relationship between v, which is the velocity at this point, and the angle theta of the plane to the horizontal, so there is apparently some sort of a relationship between the v by the time it has accelerated to a fixed point q, meaning the distance p to q is the same, and the initial velocity would be the same. What we're altering is basically likely to be the angle theta, and we're observing a subsequent change in the velocity at q while keeping the mass of the wooden block and the mass of the falling body constant, as well as attempting to minimize friction. At the pulley, we may use some sort of a lubricant. So these are some things you need to keep in mind for a standardized, accurate experiment to get good results. Alright, so we have this sort of situation. Right, and how many things are there? Like I mentioned in the previous video, you must really take into account all of the variables presented in the diagram, in the question statement, as well as in the formula, and you need to standardize all of them with the exception of the ones you are investigating. So what is B? B is the mass of the falling body, and M is the mass of the wooden block, and they have to be standard, meaning they have to be the same. The mass has to be the same in every repetition, and you actually need to know the value of the mass, and you have to use an electronic balance to get the value. And then what is S? Is distance between P and Q. Again, S needs to be the same, and you need to be able to measure. You need to have a value of S as well. You'd have to use a ruler in this scenario, and you'd have to mark P and Q using some sort of a permanent pen so it is easy to position them. And G is obviously already a constant, 9.81. But if you wanna, you may actually carry out an experiment to get the value of G in the place you're carrying out the experiment. I don't think that is actually necessary. Again, we have B and M over here, and then sine theta. B is over here, and B is also over here, and B is over here, and B is over here, and this is also over there, and these are the stuff you need to be. These are the stuff you are supposed to be investigating. Okay. Yep, and you need to, yeah, that's it. So we have to design a lab experiment to test the relationship between V and theta, no problemo there, and explain how your results could be used to determine a value for G. So that is what we want as well, a value for G. And you need to have a diagram drawn out as well. So the actual practical setup, and you need to be really careful when drawing the setup, it needs to include everything you would, like think of this, that you have a rookie and you want to explain to him how to carry out a particular experiment. You have to give each and every step. The diagram has to be on point, so the poor kid doesn't get confused too much. The procedure to be followed: measurements, variable control, analysis, safety precautions. So a good way of doing this 15-mark question is to firstly identify the independent variable, the one you're actively changing, that would obviously be theta. The dependent variable would then be the velocity, right? Because you want to change theta, then you're gonna observe a change in the velocity at point Q. And then there's something called constant variable, and these are the stuff you need to be keeping constant. So when we're talking about velocity, we are talking about acceleration as well, right? Right? So we need to keep the acceleration constant, right? The overall acceleration of the setup, and for that we need to keep the mass of the wooden block as well as the mass of the falling body a constant. Yay. You also need to keep the distance PQ constant, and you need to ensure that it always starts at U. And another possible thing is that because acceleration needs to be kept constant, what are the sort of things that could affect acceleration? Friction is likely one of them. So you need to keep the pulley sufficiently lubricated, and you need to ensure that at each repeat of the experiment, this block follows the same path, so that the surface it is moving on, its friction is sort of like standardized. Anything else you think might affect it? Yep. Now the procedure to be followed, you vary theta. And at this point you'd be like, how on earth do you do that? How on earth can you possibly do that? Well, obviously there must be a way, because this is just how do you keep the plane inclined? Obviously it's not just, you're not just using telepathy to do that, and you want an actual feasible experiment. You may use some sort of retort stand, right? A fixed distance away, and you basically, there's a thread, strong thread, that is like attaching it to some point, and by varying the length of this you may vary the angle of incline, and you may use a clamped protractor to measure whatever value of theta that you have. A better idea might be some sort of you may have some wooden blocks, and then you'd put 5 of them to get a certain angle, and you at the same position you would increase the number of the wooden blocks, so the angle is changed, right? Good. Right, so now we want to measure the velocity at a certain point. So they aren't asking the average velocity. What they want to know is the actual velocity at a certain point. And how do you do that? You may use a motion sensor connected to a data logger, and that would basically plot a distance, a displacement time graph, and then you can get a value of the velocity from the gradient of the displacement time graph at the exact moment it was at Q. There is another idea. You may put a light gate over here, and the light gate would begin the timer which is connected to it the moment this part enters, and that it would close it the moment the other part enters, and then you just divide the length of the wooden block, which you would have measured using a vernier caliper perhaps. You would have divided that by the time taken for this and this to go through the light gate. Now this is a good example of it. Now you need to keep this inclined plane stable, fairly stable at least. Because you don't want the whole setup to be jostled, right? So you measure this with a protractor, and the control of the variables is something I believe I already mentioned. And you should probably draw an electronic balance over here, and you need to show that there is a light gate over here connected to a timer, and you need to show a protractor over here, and you need to show the retard stand, and you need to label at least 2 of these things that I've shown, right? So hopefully you would get values of theta and corresponding values of v, and all of this stuff has been kept constant. And how do you analyze the data? Well, we can't just draw v. We have to actually make a graph that is a straight line, because those are the ones that are easiest to analyze. We get a curve, so hard. So you have to like manipulate this complicated equation into something that would give a straight line graph. So we have v square over here, and we have sine theta over there, and we know y is the straight line. Anything that is a straight line formation would have an equation of the form this, and we know what the y and the x are. We know that the y variable is basically the one that is being changed. That would be changed, and that is therefore v. And we know what x is. We know that x is the theta, and this makes kind of a lot of sense. So theoretically, if we plot v square on the y-axis, where do all of these things come up then? Seems a bit weird, doesn't it? So we have to alter this, because v is still on the y-axis, and then that is why we multiply this by 2s, and so we have to multiply this side by 2s as well, and divide by bb plus m, and you have to also divide this by b plus m. So this comes at bg minus mg sine theta, and this would be multiplied by b plus m, remember, not b into m, divided by, multiply by 2s divided by b plus mk. So if we plot sine theta as the x, we also have this whole, the rest of it, right? So what is that? Well, m into g into 2s over b plus m would be the m. The gradient would be equivalent to mgs. Let's put 2 over here, divided by b plus m. And don't remember the minus over here, so the gradient would actually be equivalent to minus this. Actually equate the gradient which you would have gotten, you put in the value of m, the value of s, the value of b, the value of m, you'd automatically get the value of g you want. And if the graph we drawn is a straight line graph, because we have v squared over here and we have sine theta over there, and it has an intercept that is in 0, then whatever sort of relationship that they've given is completely valid. Any sort of safety precaution, well, this falling body might hit something, so you can have a sand tray over there. You may actually draw it in the diagram, so for the ease of others. So I'll be pausing this, go over this, see if there's something you'd want me to add, and then we'll go over this together. Right. Right, let's review the general principles when doing P1. Read the question statement carefully. Do not mention any variable they may have mentioned or even implied. In this one, it is quite easy. What are the factors involved? Obviously, that would be the acceleration of the wooden block, right? And what factors would likely affect the acceleration of pretty much anything? Well, number one would be the mass, right? And G is obviously a constant. Another factor may be air resistance or friction at the pulley or friction faced by the wooden block, right? And something else, they have marked this to be the center of the wooden block. So what distance do we need to measure? Because the light gate option might not be a good idea on hindsight, because we want the distance, or we want the time it took to reach half of this value, don't we? What do you think? So actually this value would have been and this point, right? So when do we mark that as having been fulfilled? This ought to be over there. Right? So we would have an extra distance that would be equivalent to half the length of the wooden block, won't we? So we just simply have to add that distance up. Whatever distance we have of PQ, to that we will simply add the length of this. And then there's all the identification, independent and dependent, and the stability of this inclined plane might actually be a problem. So let's think about this again. The retort stunt option seems good enough, but there is a chance that it might affect the stability. So the option of using some sort of blocks to keep the plane inclined seems a teeny tiny bit better. So let's just go over the answer they have given us. Defining the problem, theta is the independent variable. Like I said, the one we will actively be changing in order to observe some sort of a change in the other variable, which we will term as the dependent variable, because it is dependent on some other factor, right? Independent and V is a dependent, 1 mark. We have to keep S a constant, yep. V squared is equal to 2 into A into S. S definitely needs to be kept constant. Oh. And methods of data collection. Labeled diagram showing inclined plane with labeled support and P and Q marked, definitely. And method to measure angle, example, a protractor to measure theta, or use a ruler to measure marked distances from which sine theta or theta may be determined, so basic trigonometry. And method of timing for an appropriate distance to determine V. Example, use a stopwatch, timer, or correctly positioned light gate connected. This is what we said, right? Correctly positioned light gate connected to a timer or data logger, or correctly positioned motion sensor connected to data logger. So the simpler option of simply using a timer and observing the distance may actually work to an extent. So actually, while I didn't say use trigonometry, might be a good option because you get a bit extra marks if you describe what lengths you need to calculate. Seems a bit unfair of me, but when you want to get the best mark you can, you'd have to do some stuff like that that is completely unnecessary. Yep. and then measurement of an appropriate distance to determine V, example rule to measure an appropriate length, or length of a cord to interrupt light beam, or distance from motion sensor to cue. Rule to measure an appropriate length or length of a cord beam to interrupt the light beam, or distance from motion sensor to cue. Yep, the wooden block one is accurate. 1, 2, 3, 4, 5, 6. Data analysis methodology, you can have a lot of mark from those as well. Plot a graph of v square against sine theta, done. Straight line is produced, not passing through the origin. G is equal to minus gradient into bm over 2ms, definitely. Something I forgot is that you just don't have to show the relationship, you have to make the G the subject. You'd lose marks otherwise, but 9 marks definite. Use cushion form for falling body, yep. So you can get a maximum of 6 marks for this. 1. Determined using trigonometry. Appropriate equation to determine V. V being 2s over t x. Repeat experiment for each theta and average V or t. Use of balance to measure the wooden block M and falling body M, and ruler to measure S. Definitely 3 marks. Clean surface of blocks, inclined plane. Ensure that the surface of the plane is smooth. Was implied but not clearly stated by me. Keep B and M constant, or keep mass of block and mass of falling body constant. 4. Method to ensure it starts in the same position. Put a mark on the block or align the front or the back. Method to prevent the plane slipping. Angle remains the same. I missed this out but still works. So if I gave this, I would have gotten 1, 2, 3, 4 from this. Five, 6, 7, 8, 9, 10, 11, 12, 13. So out of 15 I would have gotten 13. Vex for me. Find 51. Right. And it's a good idea to always read the examiner report. Really good idea. So most candidates complete the paper, no evidence of time constraint. Let's keep it that way. Most of the scripts were clearly written, yay. Question 1. Did not always describe the method in necessary detail. Remember, you're assuming that you're setting out the experimental procedure for a complete rookie who might do something really stupid if you didn't clearly note down all of the steps, and then you'd be in trouble because his parents would be there and they would be like totally mad at you. So consider that you're telling a rookie to do something completely alone and you have to literally mention everything. The methods that candidates described to determine the velocity often did not have enough detail and so did not mention the appropriate measurements. That is, how to measure B, how to measure M, how to measure S, how to measure theta, and how to measure V. These are all of the variables that need a method of measurements to be clearly jotted down by you for the examiner. And it is visible that candidates should think carefully about the experiment following the points given on the question paper, and to imagine how they would perform the experiment in the lab. Automatically, a lot of stuff you'd be missing out comes to you when you follow this approach. So more, yeah, again the same stuff. So candidates were required to investigate how the speed v of a wooden block at point Q on a plane varied with the angle theta of the plane to the horizontal when the block is caused to move through a fixed distance by a falling body. Candidates should be encouraged to spend time reading the question carefully, enable them to formulate a workable plan, and each and every symbol in the given equation ought to be properly understood. Should decide which quantity is independent, which is dependent, and then they need to consider how the dependent and the independent quantities could be measured precisely and accurately. And candidates were awarded credit for correctly identifying the independent and the dependent variables and the constant s, that is the displacement. Although on some occasion this contradicted what was written in the experimental description. Yeah, don't be contradictory. No one likes that. The number of candidates using the word control instead of the correct word constant when considering quantities has decreased. Constant variable, never control. Credit was available for drawing a clearly labeled workable diagram. Labeling is key. You will lose one very easy to get mark otherwise. Diagram should include the necessary pieces of apparatus set up as they would be in the lab. In this experiment, the inclined plane required an effective means of support with the distance s clearly marked. Like I suggested, the use of wooden blocks, and they had an important, really important idea when they said that we may have actually put a mass in order to stop the plane from slipping, to make sure that theta was constant while we were doing the experiment. That is important because when we are keeping something constant, if we also detail out how we ensure that it is constant throughout, that works really well for you. Candidates needed to give a method of measuring appropriate quantities, and the measuring instruments need to be stated and most correctly identified a way to measure theta. Many candidates suggested the use of a protractor. Many stronger ones drew the protractor on the diagram in the correct position. Other candidates suggested trigonometric methods needed to clearly indicate the distances to be measured and how they would be measured. Credit was available for the additional detail of how sine theta or theta would be determined from a trigonometric method. 2 marks were available for determining the speed v. A variety of methods were suggested, with many opting to measure s with a ruler and the time with a stopwatch. Very few candidates could produce the correct formula for calculating v, often omitting a factor of 2 in the equation, and thus determining the average velocity rather than the final velocity. And candidates who chose to use light gates often forgot that a data logger measuring time was required. Do not forget something so key. A relatively small number of candidates gave a good description of a measured length of cord attached to the block, breaking the beam of a light gate placed at Q, followed by the relevant theory. Candidates could describe methods which use either 1 or 2 light gates. Methods using motion sensor needed the motion sensor to be placed at the correct position ahead of the point Q. And answers for this method often did not contain detail of how to find V. When candidates were suggesting the use of light gates or motion sensors, a clear description of the measurements and the method is needed. Most candidates identified a suitable graph to plot, though a few suggested plotting theta instead of sine theta or v instead of v square. Fairly obvious and a very stupid mistake to make. Candidates needed to state that the relationship would be valid if a straight line was observed and that it should not pass via an origin. Obtain credit for determining G. Gradient must be used and expression rearranged to give G as a subject. Important. An additional detail section had a maximum of 6 marks that could be awarded. In general, candidates found it difficult to give enough detail to obtain these. And these candidates should be encouraged to write their plans including appropriate detail. Yep. And reason for the safety precaution ought to be given. And what was the grade threshold for this paper? 22, fairly high up there. Or was it 23? Yep, it's 23. So yeah, pretty high. Need your best for this. And this was it. Hopefully it was helpful. If it wasn't, feel free to criticize me. Constructive criticism, please. And if you like this, please like, please subscribe, and please comment.